This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Find all real numbers that satisfy the equation square root of 3 cotangent of x equals -1. So we're finding all real numbers. Remember, we're going to be thinking in terms of radians. All right, so we notice this has just one trig function. It's the cotangent of x. So let's solve for that by dividing both sides by square root of 3. So that's step 1. Cotangent of x equals -1 over square root of 3. And I like personally to think in terms of sine, cosine, and tangent. So if I take the reciprocal of both sides, in other words, if the cotangent is -1 over square root of 3, the tangent of x is negative square root of 3 over 1, which you could write as just negative square root of 3. It's up to you whether you want to write it as negative square root of 3 or negative square root of 3 over 1. Now also remember that the tangent has a period of pi. So we know that once we get one value for the tangent, if we add pi, we'll get another solution, etc. So where is the tangent negative? So we need to find one place where the tangent is negative. And we could choose either quadrant 2 or 4. And it's up to you which one you use. If you want to think of the y value as negative and the x value as positive, you would choose 4. I'm going to think of it the other way, where the y value is positive and the x value is negative, and pick quadrant 2, because I'm going to try to find the smallest value. So let's see. The y value is bigger than the x value. So there's my angle right there. So that would be my -1, square root of 3, and 2, and then we need to know what real number that is. That means in radians, what is that? If you want to first note that that is 120 degrees in degrees, that's fine, but in radians that is 2 pi over 3. So x, the first value that works is 2 pi over 3, but we can get all the other values by adding or subtracting multiples of pi or 180 degrees, because that is the period of pi. So we just add pi k, where k is an integer. And those are all the values, all the real numbers. And you could always do a check. For instance, you could put 2 pi over 3 in for x into the original equation and make sure this is true. All right, so here's another one where we're going to find the values of x in radians, but instead of choosing all values that work for x, we're just going to pick the ones in between 0 and 2 pi. All right, so let's take our equation for cosine squared x equals 3, and again we only have one trig function, the cosine, so let's isolate that by dividing both sides by 4. So we have cosine squared x equals 3/4. So to solve for cosine, you'd want to take the square root of both sides. Just like if it was u squared, you would take the square root of both sides. Now when you take the square root of both sides, what do you have to remember to do? You have to put plus or minus. All right, so we have plus or minus the square root of the top over the square root of the bottom. Square root of the top is square root of 3, bottom square root of 4 is 2. So we want all the places in between 0 and 2 pi where the cosine is either square root of 3 over 2 or negative square roots of 3 over 2. So let's look, where does that happen? All right, so that means the x value is going to be bigger than the y value, right? This is like the 30, 60, 90 degree triangle. So we've got this one here, this one here. Here's where it's going to be positive, right? Square root of 3 over 2. Here's where it would be negative, square root of 3 over 2. But we also have down here. So there's actually 4 places. Now if you want to see all those angles, you could draw them separately. You always start from the x-axis. There's that one over there. Because we're going to find values in between 0 and 2 pi, so we're only talking about positive ones. So if you were going to try to draw it, you could see how confusing that could look, but those are the angles. Okay, so I'm going to get rid of them. Just doesn't quite. Of course, I'm getting rid of too many things here. Let's put this on pause. Alright, so now it might be a little bit easier just looking at these different angles. So the first one, that's up at 30 degrees, or pi over 6. So we've got pi over 6. That's the one in the first quadrant. The one over here is 5 pi over 6. Pi is really 6 pi over 6, so this one's 7 pi over 6. And this last one, it's not all the way to 12 pi over 6, that's going to be 11 pi over 6. Again, if you want to think of it in terms of degrees and then go ahead and change everything to radians, that also is fine. And again, you could plug in these values one at a time and make sure the left side really does equal the right side. That's how you could check those 4 different solutions. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.